In this video, I'm going to talk about exponential functions. In particular, things of the form f of x equal to b to the x, where b is greater than 0, so we need it to be a positive number, and not equal to 1. And this is not what all exponential functions look like. We could change this up, but in this particular video, I'm only going to look at a number raised to the x power. If that number is greater than 1, then we have what's called a growth function. This function is going to grow very quickly. On the other hand, if it's between 0 and 1, it's called a decay function. It's going to be getting smaller. The domain of these functions is always going to be negative infinity to infinity. If I have a positive number, I can raise it to any power that I want. The range, however, raising a number to any power will always result in a positive number. If I raise a positive number to any power, I still get a positive number. So my range will be 0 to infinity. Let's consider the function f of x equal to 2 to the x. And I want to graph this. So I'm going to start by building out a table and seeing what happens. I'm going to let x be 2, 1, 0, 1, and 2. Negative 1 and negative 2. 2 squared is 4. 2 to the first power is 2. 2 to the 0 power is 1. 2 to the negative 1/2 power, negative exponents move it to the bottom of the fraction, so I have minus 1/2, and then minus 1/4. Graphing this, we have the point 2, 4, so we'll go over 2 and up 4, over 1 and up 2, over 0 up 1, left 1 and up 1/2, left 2 and up 1/4, and we could continue this as well. Here would be 3 and 8, and then we connect the dots. Didn't do a great job here, but we get the general idea. We can see that, as I called this a growth function, as we move from left to right, we get bigger. And we can also see my range is 0 to infinity. I always stay above the x-axis. This time I want to look at f of x equal to the 1/2 x. So this time my base number is between 0 and 1. 1/2 squared is 1/4. 1/2 to the first power is 1/2. Anything to the 0 power is 1. A negative power flips the fraction, so this is a 2, and then 2 squared. And then 2 squared gives me 4. I then have the point negative 2, 4. So we can plot that. Negative 1, 2. 0, 1. 1, 1/2. And 2, 1/4. And once again, we can try to connect the dots. And we get our decay function, since this time we're between 0 and 1. As you move from the left to the right, our function gets smaller. Here I have a graph, and we can see that as b gets bigger and bigger, the graph does have the general shape that I showed in my example. Here would be 2 to the x like I did. However, the bigger and bigger I get, the steeper and steeper this curve gets. So if we go down a little bit, we can see that it gets steeper and steeper the bigger the base gets. On the other hand, if we pick something less than 1, between 0 and 1, here would be 1/2, the one I looked at in my particular example, and the smaller and smaller I go down, the steeper this graph gets on the left. So the value of the base just tells me how steep of a graph this is, as well as if it's increasing or decreasing.